In this video, we're going to learn how to solve problems involving work, energy, and power for your physics. So we're going to practice with 10 repeated questions for this topic. Alright, so let's get started. Let's begin with the first one I have here. It says, which of the following quantities has the same unit as watt? So we have the first option, force times velocity. The second option, force times distance. The third option, force times time. The last option, force times acceleration. So the correct option in this question is option A. Force times velocity has the same unit as watt. Alright, so take note of this particular question. I have often seen it repeated. Let's go to the next repeated question, which is this one. So it says, calculate the kinetic energy of a body of mass 15 kg that started from rest and traveled a distance of 50 meters with an acceleration of 1 meter per second square. Okay, now to solve this question, we know that kinetic energy KE equals half mv square. Okay, so in this question, of which I highly recommend you begin by getting out your parameters to know what you're working with. So we have the mass to be 15 kg. We don't have the velocity actually, so we can't solve this question with this just mass we have. So we need to get the velocity, and also in this question we have this parameter. We have distance x to be 50 meters. We have acceleration to be 1 meter per second square. All right, we have our initial velocity from rest u equal 0 meter per second. We are looking for the final velocity so that we can substitute it in this formula to get the kinetic energy. Now we're going to apply one of the equations of motion to get the final velocity. We're going to make use of v square equals u square plus 2ax. all right, so our v square, we might want to make v the solid formula. V square equals, our u is 0, that's 0 square plus 2 times our a is 1 times our distance x is 50. All right, so this is the same thing as 0 square is 0, so 2 times 1 times 50, we're going to have 100. Now to make v the solid formula, we're going to square root both sides. So this square will cancel the square root. Our v will now be square root of 100 is 10 meter per second. So at this juncture now we are getting the final velocity to be 10 meter per second. So let's substitute it in this expression we have here. So this same thing as, so we have half times our mass is 15 mv square, so our v is 10 square. Okay, so this is something as half 15 times 10 square is 100. all right, so 2 cancels a 1, 2 into 100, we have 50. So let's punch this on the calculator. So we have 50 times 15, we have the output to be what? 750 joules. That would answer this question, option D, 750 joules. That's it for this particular question. Let's wipe this now and solve the next repeated question. Let's remove this. Alright, so the next repeated question we're going to solve will be this question. It says a force of 100 Newton is applied to a bus, causing it to move 5 meters in the direction of the force. If the angle between the force and the displacement is 60 degrees, how much work is done? Now for this kind of question, we know that the formula for work is force times distance, and in this question we have an angle involved, so basically it's going to be force times distance because of this angle times cos 60 degrees. All right, so that's all you need to solve this question. So let's go ahead and simplify this. Our force in this question is 100 newton, so we have 100 times our distance is 5 times cos 60 degree, and of course cos 60 degree is something at 0.5, okay, which is half. So let's punch everything together here on this calculator. So we have 100 times 5 times 0.5. So we have it to be what, 250 joules. That will be the work done. Alright, so that's it for this particular question. Let's wipe this now, solve the next repeated question. Okay, so the next repeated question will be this. It says a body accelerates uniformly from rest for a time t. The kinetic energy of the body at t is, we have I is directly proportional to the displacement II is directly proportional to the square of the instantaneous velocity. III is directly proportional to square of the time t square. IV depends on the value of the acceleration. Which of the above statements is or are correct? Alright, so for the statements we have above, the correct option to this question will be option D, because the four statements we have above are all correct. Alright, so the correct option will be option D. That's it for this particular question. Let's go to the next repeated question. So it says a vehicle of mass M is driven by an engine of power P from rest. Find the minimum time it will take to acquire a speed. Alright, now guys, also take note of this particular question. From the options we have here, the correct expression for the minimum time it will take to acquire a speed will be option B, mv square over t. That's the correct expression for this question. Take note of this particular option, mv square over t. Alright, so that's it for this one. Let's go to the next repeated question. This one, the correct option is option B, mv square over t. So the next one we have here says, which of the following statements is correct for a freely falling body? Alright, so guys, before we attempt this question, if you are new to our channel, ensure that you are subscribed to this channel for more of our videos. We really appreciate this. Alright, so let's look at what we have. We have I, the total is entirely kinetic. The ratio of potential energy to kinetic energy is constant. The sum of potential and kinetic energy is constant. We are asked which of the following statements is correct for a freely falling body. So basically the correct option in this question will be option A, I only. The sum of potential and kinetic energy is constant. That's the correct option here. Alright, so that's it for this particular question. Also take note of this one. Alright, let's go to the next repeated question. So the next one I have here says, in the figure above, the work done by the force of 100 Newton inclined at an angle of 60 degrees to the object dragged horizontally to a distance of 8 meters is what? Okay, now the formula for work is force times distance, and we have an angle inclined at 60 degrees to the horizontal. It will be times cos 60 degrees. Now note that had it been the angle was inclined to the vertical, this would have been sine 60. So when angle is inclined to the vertical, it will be sine. When it's inclined to the horizontal, it will be cos. So let's get this. Now it will be 100, which is the force times the distance. We have it to be 8 times, now cos 60 is 0.5 or half. So let's punch this on the calculator. So we have 100 times 8 times 0.5. So we have the output to be what? 400 joules. The correct option in this question is what? Option A, 400 joules. So that's it for this particular question. Let's wipe this now, solve the next repeated question. Alright, so the next repeated question will be this question. It says a body of mass 800 grams starts from rest and accelerates uniformly at 2.5 meters per second square if a distance of 12.8 meters is covered. Calculate the kinetic energy gained by the body. Alright, so let's get the parameters for this question. Remember, kinetic energy equals half mv square, and in this question we have our mass to be 800 gram. Basically I need to convert it to kilogram, the standard unit. To do this, it will be 800 divided by 1000. Okay, so we will be left with 0.8 kilogram. Okay, this is kilogram, and we have our, in the question we have our initial velocity start from rest u to be 0 meter per second. We have our acceleration to be 2.5 meter, this is 5 meter per second square. We have the distance x to be 12.8 meter. We now have the v, final velocity is unknown, so we are going to apply these equations of motion to solve it, which is we have v square equals u square plus 2as. So our u, this is 0 square, okay, plus 2 times our acceleration is 2.5 times our distance is 12.8. So let's punch this on a calculator and see what's going to give us. We have 0 square is 0, so we have 2 times 2.5 times 12.8, so we have 64. Okay, let's write this down. We are left with v square, this is v square, equals 64. So to make this formula, use square roots both sides. This is square, so this square I cancel this square root here. So square root of 64 will give us 8. So our v equals what? 8. Let me write it here. V equals 8 meter per second. Our final velocity, let's now plug it in this formula we have here. So this is going to give us half, okay, times our mass is 0.8 times, we have half mv square. Our v is 8 times 8. Okay, 2 cancels f1, 2 into this, we have 4. So let's punch everything together now on the calculator. We have 0.8, okay, times 8 times 4. Let's check. So we have the output to be 25.6. The correct option in this question is option A, 25.6 joules. Alright, so that's it for this particular question. Let's wipe this now, solve the next repeated question. Okay, so the next repeated question will be this question. It says a body accelerates uniformly from rest for a time t. The kinetic energy of the body at t is, I think we have answered this question before. The correct option will be option B. So all the above statements are correct. Okay, so here it will be option B, I, and IV. So lastly, before I call it a class, let's look at this question. It says, which of the following fields is a non-conservative field? Option A, heat field. Option B, the magnetic field. Option C, the gravitational field. Option D, the electric field. So right, the correct option in this question is option A, the heat field. Heat field is a non-conservative field. Okay, so that's the right option to this question. It's as simple as this. Hope there's something interesting from the video. Let's call it a video, guys. We practice with 10 repeated questions under this topic: work, energy, and power purchases. Now, if you are new to our channel once more, ensure that you are subscribed to this channel for more of our videos. Also, like, share, and comment on this video. Let me know how you feel for what I learned from this video. If you seem to have any specific questions as regarding what I've talked about in this video, feel free to leave your question on the comment section below, and I'll ensure to give you a response. Also, ensure that you are part of our channel membership by hitting the join button, and you'll be glad you did. In our channel membership, we share special information to those there that goes a long way to help them out in the academic work. So click on the join button to be part of us, and you'll be glad you did. Now click on the screen above, and I'll see you in the next video. Thanks for watching.